Can I ask you to go to 45? We're going to go to 45 and just review this a little bit. And I'm going to give you class time to try another one. Because this is most definitely going to be on the test. And portions of this on the exam as well, which is coming up. Next thing you know, you're going to be writing your exam. And let's hope and pray that it's not going to be plus 40 outside when you're in the theater, huffing and puffing, right? So 45, what is it that we did here? Our goal was to demonstrate whether or not data is normally distributed, because not all data is. I kind of walked you through the steps. So there's not a whole lot of new things on here. Find the mean, standard deviation, all of that stuff. Find the MCTs, right? Mean, median, mode. The next thing we did was this. This is what we call a frequency line. Frequency line, okay? So whenever you get an assignment and I ask you to do a frequency table, you don't need to do a frequency table. I'm okay with a frequency line. This is basically a table, but it's sideways instead of usually we stack it like this, right? And this is just so much easier because you just put your mean in there, add a standard deviation, go 4 up, go 4 down. Now you have your bins, and you place your values in these bins. Okay, that's our goal, to organize it somehow. We take this information and we analyze to see if it follows this rule. Okay, so this is what we're after. Is is it distributed that way? Are the collections we've done, is it going to follow that format? So I'm going to add some highlights here. Plus or minus 1 standard deviation. If this is your mean, it encompasses everything from here to here. Okay, so we're wondering, is this chunk here, the data that is accumulated in there, does that fit? Is that going to fit my 68%? And it failed. It failed, right? We were way over. There's way too many in the middle. Okay, and then we went further out. We considered plus or minus 2 standard deviations. So from the middle, you go 2 to the left, and you go from the middle 2 to the right. And we're supposed to have 95%. This is going to get messy. So you highlight at your own risk, okay? You do what you need to do. But I just need you to understand, right? We were adding up everything 2 standard deviations to the left and 2 to the right. So basically everything that fell in there gets added up. And if you want to make it quick, I just take 41 and then I add up the 1 and the 3, right? Whatever is yet outside, because we know this is 41. So I just add the 3 and the 1 to it. And next thing you know, you have your second kind of cluster. 45 over 50, you divide up, multiply by 100. I was rushing yesterday, so I hope you understand that I did multiply this by 100 to give me the percentage. I always do. I don't necessarily show it there. And you know what? 3 standard deviations, I'm not even going to highlight there. Usually it's 100% actually. And that's okay because 99.7, which is what we want, is very close to 100, so it won't affect. So usually it will fail here right at the beginning, or maybe it will fail when you get to the second one. And remember, how much can you be off by? 5%, right? It can be. So if it fails if it's more than 5% off. Okay, that's the key here. It fails when it's more than 5% off. Okay. So we're going to do that one more time because I was kind of flying through. I assigned page 47. I posted the key to 47 and 48, I believe. So this is, I'm gonna say, so we're all on the same page because I only assigned 47. I'm gonna try, let's do 48 together. So 47 is still up to you to do. So we're gonna go to 48. We're gonna try that one. Um, and can you just put your finger on this page, and we're gonna go back, way back, because I made a mistake in our notes. Yeah, I need that special sound effect on hand. The duck. Where is this? Mm, just keep your finger on the page you are on, 48. Oh yeah, on page 36. This one right here. When Lee interrupted me, which was great, I got this one wrong. Okay. So 36, way at the top, question J. So you're gonna have to do some erasing here. It's asking us to determine the z-score of a bag that is lighter than 31% of the bags produced. This is not saying that. This is not saying it's lighter than 31%. This is actually, the z-score here would represent is heavier than 31%. Like if you interpret it this way, it's wrong. Okay, so I'm gonna erase this, and that is my bad. I take full responsibility for that one. Maybe I should retire early. Right? All right, there you go. This is my cue. So, do you want the z-score, right? That is lighter than 31% of the bags produced. That's what's happening. It's lighter than. Okay, so this is what you should interpret. And we put it higher up because if 31% are to the right of you, you have to be further up on the curve. So this is wrong, right? What's wrong with this picture? If I set this up like this, let's say I actually gave you a diagram like this, and I ask you for the z-score. What's wrong with it with the entries here? The 31, it's not right. Because we know that if this is 31, then this is 69, right? So this would be 0.69. And so that would be a different answer, correct? Do you have the answer for this one? The correct answer? It is 0.5 still? Oh, not negative, it's positive. Okay. Okay. So that's the only thing that changes. But it is a big difference, right? Negative versus positive. It's if you had a negative, you're somewhere in here. If it's positive, you're somewhere up there. So let's fix that. Thank you guys. I apologize. I guess it just goes to show, read your questions carefully. Okay. Let's go back to 48. So here it is again. Create a frequency table using the standard deviation as your interval width. You can just go frequency line. This is only going to be okay if you're trying to show whether or not data is normally distributed. Okay? And trust me, on a quiz or test, I will say frequency line. I've changed that. So you don't have to worry about like what's happening here. So I want you to obviously first and foremost find your mean and your standard deviation. That is the first thing you need to do. So go ahead and do that. Type in all these values into your L1. I'll pause the video here. And my standard deviation is 18.03. It's so easy to mix these up, right? standard deviation, and so you got to make sure you pick the right one. And what's n? I always like to write down. It's 29. It's a purposely chose something that wasn't always a nice even number. Here we go. Let's make our frequency line. See how fast you can do it, because you don't want to spend too much time, okay? Because you can eat up a lot of time if you don't do this right. And you know what? I'm going to make my bins a little bigger this time. So there, one. So this is my mean in the middle. I'm going to make it a bit longer, right? So 1, 2, 3. 1, 2, 3. And you go 72.31 in the middle, and then just add a standard deviation every time. Grab your calculators for this. So if you practice this, you'll get really good at it. And you might ask, what about the 4 standard deviations? Didn't you do 4 and 4? I will stay with 3. If I need to, I will add a bin, okay, if I need to. Because quite often it's not necessary. So 72.31 minus a standard deviation, because now we're going to the left. I added 36.25, 18.22. There we go. You could, after you've done this, you could technically draw a histogram of frequency polygon, no problem, right? Just put this along the x-axis, you add a y-axis, and then you go for it. So let's put the numbers into these bins. So we got to go stat sort. You got to sort your data points. I at least would do that. It's so much easier. And then start plugging them in. So 30 would get you in here. So you got to be careful where you put your numbers, right? So 30, 40 already puts you in here. 48, you're still in here. 51, you're still in here. 53, you're still there. 54, you are still in this bin. 56 puts you over to the next one. 64, 65, 66, 67, another 67, 67, 68, 73. So that puts me over on this bin. 73, 73, 76, 80, another 80, 81, 87, 87, 88, 92. That puts me already over to the next one. 93, 94, 98, 99, 100. That's it. And I always like to put the numbers at the top. So 1, 5, 8. This is 9. And then you've got 6 there. And remember, this is your mean here at the middle. This will be -1 standard deviation, -2 standard deviation. So if you need to do that, because you're still getting the hang of this. So we did our frequency line with the standard deviation as our interval width. So we're good there. Draw a histogram using the info in A. Sure, why not? So this is A, this is B. I just want to show you that you can. Actually, you made it very easy on you. So you just go ahead and it's your X and Y axis. What do these scores represent? What are the units, right? Scores as a percentage down the X-axis. This would be frequency. So it'd be number of students. And what's the highest? We go to 9, right? So I'm going to go 2, 4, 6, 8, 10. That'll do it. Most of the time on a quiz or something, I give you a grid most of the time because I like nice graphs, and if you do it by hand, it doesn't always work out. And then I'm going to go zipper, and here I will use a ruler for this part. I'm just going to say this is where I'm going to start. I'm going to go 2 centimeters. Let's see here. Start, so 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. That works pretty good. So then you just copy those numbers down. You've already done the work. So your scale is your standard deviation. There you go. So it's just prettier, it's drawn to scale, all that jazz, right? So you've got 1 for the first bar, so it just goes up 1. And you're like, is this a histogram? This is a histogram. There's histogram and then frequency polygon. On the AC that you're gonna do, I make you review line plots. I don't know if you remember. That was like one of the very first things we've done. Don't want you to forget how to do those. It's 8. So you might have to erase a bit. And then we have 9, so it's a little higher. Let's use a ruler. And then we've got 6. So it's lining up with the 6 on the side. There we go. So 1, 5, 8, 9, 6. It kind of looks normally distributed, doesn't it? You're like, well, there's a big jump here, but overall it kind of looks symmetric. So we'll check for that. Let's see. If we have time, I'll do a frequency polygon over top of this. So to be honest, I would just make a histogram and then go frequency polygon over it if all I ask is a frequency polygon, because it's so much easier to once draw your bars and then just make the points in the middle and connect them over top. I'm fine with that. Is data normally distributed? Does it follow, right, the 68, 95, 99 rules? We're going to go plus or minus 1 standard deviation. We're going to check. Remember, we know we have 29 values to compare to every single time in this case. So we just add. You can either use this bar graph here, or you can go way at the top. So it's 8 plus 9, right? So 17 values. So that's 17 out of 29 times 100. Let's check. So just go 17 divided by 29 times 100. It's 58.6%. It's about 59%. versus 68%. So fails. You're off by more than 5%. Okay, so we're done there. Stop. You don't have to keep doing 2 standard deviations, 3 standard deviations, because you already know that it's not going to work. Okay, therefore, data is not normally distributed because it does not follow 68, 95, 99 rule, 99.7 rule, the empirical rule. Okay. I'm going to stop there. So I will post everything from 47, so page 47, all the way to, I believe, let me just check because I have it ready here. Oops. All the way to 50. I have everything to 50 done. So trust me, some of them are normally distributed. They're not, I'm just showing you the knots because in the past I always showed the ones that work, and so students just thought it's always going to work, right? So it's up to you. So up to you how you want to use the rest of your time. I would strongly encourage you to do one more before you go home today. You should probably be able to get it done. Or you want to start on the ACs, that's completely up to you. Maybe I'll just talk about. Oh yeah, the ACs. By the way, hint hint. One of them, I ask you to make a frequency line and to show whether or not. So if you want to do that one, but if you're not sure yet, you want to practice one more time, you go for it. So inverse norm, inverse CDF, inverse norm, sorry, and normal CDF, you're going to use that. If you do the AC, okay, and there's 1 or 2 questions blank, I'm okay with that, okay? But if there's like a full page blank because I didn't understand it, I'd rather you have something on there, and if it's wrong, then we'll fix it. But if it's a complete page is blank, I don't know, like put an effort in. And I can see that one question you might not know how to do, but that's okay, right? We'll fix it when we come back next week.